All right, welcome to the deep dive. Today, we're going deep, really deep, into the world of data engineering.
Yeah, and we're going to see if we can chart a course, from starting from scratch to becoming like a real pro.
Exactly. Man, we know perfect data engineer, that's like a pretty high bar.
Yeah.
We're not expecting you to walk out of here like building data pipelines, right after this episode.
No, not at all.
But what we do want to give you is that solid understanding, that roadmap, that foundation
Yeah.
of how to go from maybe zero experience
Hmm.
to being pretty darn confident in this field.
Absolutely. Whether you're just sort of curious what this whole data engineering thing is about. Maybe
Mhm.
you have a meeting coming up and someone's going to talk about it and you want to be able to follow along. Or you're thinking, hey, this sounds cool. I want to learn more.
Yeah,
This is for you.
this is for you.
We're going to break it down.
Yeah, piece by piece.
What it is, the how, the why, the whole 9 yards.
And we're kind of setting an ambitious goal here, aren't we? We want to pack so much good stuff into this episode that if you were to really put in like some focused effort afterwards, you could potentially
Yeah.
gain almost like an accelerated path towards some level of expertise.
Yeah.
We're talking maybe a couple weeks if you really hit it hard. It might sound intense, but we've kind of cherry-picked the best parts.
Yeah, the core stuff, the essential stuff, the meat and potatoes, so to speak.
Right, to give you that like maximum impact without totally overwhelming you.
That's right. We want to cut through the noise, give you that clear path, make you feel empowered,
Yeah.
and understand data engineering. It can be a complicated beast, so we've gone through it all, pulled out those key insights.
Okay, so let's jump right in. What is data engineering at its core?
All right, so data engineering, in the simplest terms, it's about building and managing the infrastructure for data.
Right.
The roads, the pipelines, the storage facilities, if you will, for the data that flows through an organization.
Oh, I like that. Roads and pipelines for data. So what does that actually look like?
Well, a big part of it is building these things called ETL pipelines, stands for extract, transform, and load.
Okay.
You're pulling data from all sorts of places, cleaning it up, shaping it, and then loading it into a system where it can be analyzed.
Got it.
And making sure that data is high quality, easily accessible, that's a top priority.
So ETL pipelines, that's the bread and butter. What are some of the technologies involved?
Oh, there's a bunch. You've got your databases could be your traditional relational ones or more modern NoSQL databases. Then you have big data technologies like Hadoop, Spark, Sloot. These are essential for handling massive amounts of data.
Okay.
And of course, you've got data warehousing solutions. Think Amazon Redshift, Google BigQuery, powerful platforms for storing and analyzing all that data.
So all this is really about making data usable in the end, right?
Absolutely. It's about empowering organizations to get those valuable insights from their data.
Right.
Make smarter decisions, drive their business forward. You could have a goldmine of data, but without the right systems, it's worthless.
Totally. Now, data engineer, data scientist, data analyst, sometimes these all get a bit jumbled.
Yeah, good point. It can be confusing.
How do they fit together?
So think of data engineers as the builders, the architects. They create that solid foundation.
Okay.
Then you've got data scientists and data analysts. They're like the researchers, the interpreters. They use that foundation to explore, to ask questions, to find meaning in the data.
So data engineers work behind the scenes.
Mostly, yeah. They're making sure the data is clean, accessible, flowing smoothly to where it needs to go.
Got it. And you mentioned big data a few times. It seems like a big reason why this whole field has become so crucial.
Oh, absolutely. Big data really highlights the need for data engineering.
Right.
Historically, IBM defined it with those 3 Bs: volume, variety, and velocity.
All right, let's break those down for our listeners. Volume, that's just the sheer amount of data.
Right. Exactly. We're talking mind-boggling amounts. Platforms like Facebook, Twitter, they handle millions of gigabytes every day. Every minute, there are hundreds of thousands of tweets, millions of messages, billions of Google searches.
Wow.
And even your own online activities, social media, browsing, it all adds up.
Right.
Traditional systems just weren't built for this kind of data deluge.
Okay, variety, it's not all neatly organized spreadsheets anymore.
Nope, not at all. We're talking different types of data.
Okay.
You still have your structured data, nice and organized in tables.
Right.
But now we've got tons of unstructured data, audio, images, video, even just raw log files.
Oh, right.
And then there's semi-structured data like XML, JSON, somewhere in between.
So data engineers need to wrangle all that.
Yeah, they need systems that can handle everything.
Right, and velocity.
That's the speed, the pace, Data is being generated faster and faster. Think about it. Early computers, slow and steady. Then the client-server model, more users, more data. Internet boom, web apps, data explosion. And now,
Mobile devices.
mobile devices, social media, the Internet of Things, everything's connected, generating data constantly.
Okay, so we've got mountains of data, all kinds of formats coming in fast.
Yeah.
But the point isn't just to have the data, right? It's about getting value from it.
Exactly. The real challenge is extracting useful information, making sense of it all. That's where data engineering comes in.
Got it. So it's not just about storage and speed, it's about unlocking the potential of that data.
Absolutely. And there's actually a fourth V that people talk about now, too.
Oh.
Veracity.
Veracity.
It's about the accuracy and consistency of the data, because if the data is bad, the insights are useless.
Oh, right. Garbage in, garbage out.
Exactly. Data engineers have to make sure the data is clean, reliable, that it actually means something.
Okay. Volume, variety, velocity, and value, all underpinned by veracity.
Yeah, that's the landscape.
So let's get practical.
Yeah.
How do you become a data engineer? What skills and technologies do you need?
Okay, this is where it gets interesting. Don't worry, we'll break it down. Let's start with big data technologies, since they're kind of central to everything these days.
Okay, first up, Hadoop. I hear that name everywhere.
Yeah, it's a big one. Basically, it's an open source framework for storing and processing really, really big data sets.
Right.
The key is that it's distributed, meaning it uses a bunch of computers working together rather than one giant supercomputer.
Oh, okay.
The core of it is HDFS, the Hadoop Distributed File System.
Right.
Imagine you have a huge file, like 500 megabytes. HDFS splits it into smaller chunks called blocks and stores each block on a different machine.
So it's spreading the data out.
Exactly. And it makes copies of each block, so if one machine crashes, you don't lose anything.
That's smart.
Yeah, fault tolerance is key. And if you need more storage, you just add more machines.
Easy to scale.
Easy peasy. And the beauty of it is you can store any kind of data, structured, unstructured, doesn't matter.
Okay.
You don't have to define a rigid structure beforehand, you just dump it in.
Schema on read, you said before.
You got it. Define the structure only when you need to analyze it.
So Hadoop's great for storage. But what about processing all that data, especially when speed is important?
That's where moving processing to data comes in. Instead of moving all that data to a central processor, Hadoop lets you process it right on the machines where it's stored.
Oh, interesting.
It's a master-slave architecture. A central node manages tasks, but the actual work happens in parallel on those data nodes. And there's this component called Yarn that helps manage all the resources.
So Hadoop's the foundation, and Yarn keeps things running smoothly.
Precisely. Now, another big player is Spark.
Spark. I hear that a lot with big data, too.
It's another open source framework, but it's specifically designed for speed, especially with real-time data.
Okay.
Like Hadoop, it's distributed, but it's faster and more efficient for certain tasks.
Oh, right.
It has this thing called the Spark core engine, which does the basic work. Then you have Spark SQL for working with structured data, Spark Streaming for real-time data streams, MLlib for machine learning, and GraphX for graphs.
So Spark's like a Swiss Army knife for data processing.
You could say that, yeah. And it plays nicely with Hadoop, too.
Oh, cool.
Now, you mentioned real-time data, and there's another technology for that, Kafka Streams.
Kafka Streams.
It's a library for building real-time applications, and it works with Apache Kafka, which is a platform for streaming data.
Okay, so Kafka's like a pipeline for data, and Kafka Streams lets you build apps that tap into that pipeline.
Exactly. It's really powerful for applications where you need to react to data instantly. It can scale up or down automatically. It's fault tolerant, and it guarantees that each piece of data is processed exactly once.
Wow, that's important.
Definitely. And the logic for these applications is often represented as a stream topology, which is like a flow chart of the processing steps.
Okay, so we've got the storage and processing covered with Hadoop, Spark, and Kafka Streams.
Yep.
But what about the databases themselves?
Ah, yes, the databases. We've got a whole world beyond those traditional SQL databases now.
No SQL.
No SQL, exactly. They came about because relational databases weren't really cutting it for the sheer volume and variety of data we have today.
Okay, so what's the difference?
Relational databases, they're great for structured data, where everything's neatly organized in tables with rows and columns.
Right.
They have strict schemas, and they're really good at enforcing data integrity.
So very reliable.
Very reliable. But they can be expensive to scale, and they're not always the best fit for unstructured data.
Got it. And NoSQL databases are more flexible.
much more. They don't require strict schema, so you can store different kinds of data more easily.
Okay.
They scale well, and they're often more cost-effective. Now, they might not offer the same level of data integrity as relational databases,
Right.
but they have different ways of ensuring consistency that are appropriate for their use cases.
So what are some of the main types of NoSQL databases?
Well, there are key value stores, which are super simple and fast for retrieving data based on a key.
Like a lookup table.
Yeah, exactly. Then there are document databases like MongoDB.
Okay.
They store data as documents, usually in JSON format. No need for a predefined schema. And they often have features like indexing and replication.
Flexible and reliable.
Exactly. Then there are column family stores like Cassandra.
Okay.
These are designed for high scalability and availability. They're great for applications with lots of read and write operations. And finally, we have graph databases, which are specialized for storing data with lots of relationships. Think social networks.
So different databases for different needs.
That's the beauty of it. Now, beyond the specific databases, you need some core skills, like programming.
Programming, yeah, that's essential for any kind of data work, right?
Absolutely. You don't need to be a master coder, but you need to understand the basics.
Right.
For beginners, Python is a great choice.
I hear that a lot.
It's relatively easy to learn, and there's a huge community and tons of resources.
So you're not alone if you get stuck.
Not at all. R is another popular language, especially for statistics and data analysis.
Okay.
It's a bit more specialized, but very powerful.
So Python for general purpose, R for more stats-heavy stuff.
Yeah, you got it. And then there's ETL and data warehousing. Those are crucial, too.
Right. We touched on ETL before, getting the data ready for analysis.
Exactly. Data warehousing is about creating a central repository for all the data in an organization.
Okay.
And ETL is the process of getting the data into that warehouse.
Right. Extract, transform, load.
You extract the data from different sources, transform it by cleaning it, standardizing it, and then load it into the warehouse.
So it's all about making that data usable for analysis and reporting.
Precisely. There are lots of tools out there for ETL Informatica, Talend, ClickView, just to name a few.
And which one would you recommend for someone starting out?
Talend Open Studio is a good one. It's free, and it has good support for big data.
Free is always good.
Always good. Now, we can't talk about data engineering these days without talking about the cloud.
The cloud, yeah, that seems to be where everything's headed.
It is. Platforms like AWS, Azure, GCP, they've become essential for data engineering.
Right.
They offer a ton of services that make everything so much easier, building pipelines, storing data, running analyses, you name it.
So they take care of a lot of the infrastructure, and you can just focus on the data.
Exactly. Let's take Azure as an example.
Okay, Azure.
Okay.
What are some key services a data engineer should know about?
One of the big ones is Azure Data Factory. It's basically a cloud-based ETL and data integration service.
Okay.
You create these things called pipelines, which are workflows for moving and transforming data.
Right.
You connect to your data sources, do your transformations, and then load the data into a destination.
So it orchestrates the whole data flow.
Exactly. And it integrates with other Azure services, like HDInsight for Hadoop and Spark, Data Lake Analytics, even machine learning.
So it's all connected. What about database services on Azure?
Well, they have a bunch. One is Azure SQL Database. It's a fully managed relational database service.
Yeah.
It offers different deployment options, purchasing models, service tiers, basically. You get a scalable and reliable SQL database in the cloud.
Sounds easy enough.
It is. And for NoSQL, there's Azure Cosmos DB.
Cosmos DB.
It's a globally distributed, multi-model database. It can handle all sorts of data, documents, key value pairs, graphs, even columnar data.
So it's pretty versatile.
Very versatile. It's designed for applications that need low latency and high availability, like web and mobile apps.
All right. What about storing really big data sets, like those unstructured ones we talked about?
That's where Azure Data Lake Storage comes in. It's built for big data analytics. You can store any kind of data, structured or unstructured, and it's super cost-effective for large volumes.
So it's like a giant data lake in the cloud.
You got it. And for running big data processing jobs like Spark tasks, there's Azure Databricks. It's a managed Spark service that integrates with other Azure services like blob storage and data lake storage.
So you can do all your Spark work right there in the cloud.
Exactly. And they have a nice notebook environment for writing and running code, which is really helpful for collaboration.
Right. And there was one more Azure service you mentioned, Azure Synapse Analytics.
Ah, yes, Synapse. This one's a big data warehouse. It's designed to handle massive amounts of data and run complex queries really fast.
So it's the big guns for data analysis.
You could say that. They often use a layered architecture called the medallion architecture.
Medallion architecture.
Yeah, you have a bronze layer for raw data, a silver layer for cleaned and standardized data, and a gold layer for business-ready data.
Okay, so it's like a hierarchy of data quality.
Exactly.
Yeah.
Now, beyond all these cloud services, there are some fundamental skills that are essential for any data engineer.
Right, regardless of the platform.
Exactly. One of the most important is SQL.
SQL, yeah, that's the language for working with databases, right?
It is. And even though NoSQL databases are becoming more popular, SQL is still incredibly important.
Okay.
You'll use it for querying data in relational databases, data warehouses, and you'll even see SQL-like languages used in other tools.
So SQL is a must-have.
Absolutely. And another key skill is data modeling.
Data modeling.
It's about designing the structure of your databases and data warehouses.
Right.
A good data model makes everything more efficient and performant.
So you need to think about how the data is organized.
Exactly. It's like designing the blueprints for your data infrastructure.
This is a lot to take in. No wonder data engineers are in such high demand.
Yeah, it's a specialized field for sure, but don't let that discourage you. You don't need a fancy degree to become a data engineer.
Okay, that's good to hear.
What you do need is a willingness to learn and a lot of practice.
So dedication is key.
Absolutely. And the good news is there are so many resources available online these days.
Right, those YouTube courses we mentioned.
Exactly. You can learn a lot on your own at your own pace. But the key is to actually do stuff, to get your hands dirty.
So practice, practice, practice. What would be your advice for someone who wants to get started?
First, pick a language like Python and start learning the basics.
Okay,
Brush up on your SQL skills.
got it.
Then explore those free tiers on cloud platforms like Azure. Play around with Data Factory, create a simple database.
Get some real-world experience.
Exactly. And find a data set that interests you and try a small project. Clean the data, analyze it, maybe build a simple pipeline.
So start small, but actually build something.
Exactly. And share your work on GitHub, network with other data engineers, and never stop learning.
And it sounds like data engineers are needed everywhere, not just tech companies.
Oh, absolutely. Finance, healthcare, e-commerce, government. Every industry needs people who can handle data.
So there are a lot of opportunities out there.
Tons of opportunities. And it's not just a technical job either. You need to be a problem solver. You need to be creative.
Well, we've covered a lot in this deep dive.
We have.
From what data engineering is, to the challenges it solves, to the technologies and skills you need.
We even took a tour of some of the services on Azure.
And while becoming a perfect data engineer in 2 weeks might be a stretch,
Yeah, probably a bit ambitious.
this deep dive should give you a really strong foundation.
A roadmap for your journey.
Remember, continuous learning, hands-on experience, and that dedication are key.
Those are the ingredients for success.
So for anyone listening who's feeling inspired,
Yeah.
explore those technologies we talked about, pick a project, get your hands dirty.
And check out those YouTube courses. They're a goldmine of information.
All right, as we wrap up, here's a final thought for you. With all this data exploding around us, how do you think the role of the data engineer will evolve?
Good question.
What new skills will be needed? It's something to ponder as you explore this world of data.
It's a fascinating world out there.
Thanks for joining us on the Deep Dive.
See you next time.